Hello, everybody. Today we shall try to solve problem number 3 from the 28th Junior Balkan Mathematical Olympiad. The text is pretty short. We need to find positive integers x, y, and z that satisfy the equation 2020 to the power of x plus 2 to the power of y equals 2024 to the power of z. One solution is pretty much obvious. X equal to 1, y equal to 2, and z equal to 1. And maybe we even find out that this is the only solution, but we need to prove that. So let us try to write something. The equation is 2020 to the power of x plus 2 to the power of y equals 2024 to the power of z, and we are looking for natural numbers x, y, and z, or in another way, positive integers. So first, we are going to factorize those big numbers 2020 and 2024 to find out their divisors. So we divide by 2, this is 1010, we divide by 2, this is 505, we divide by 5, this is 101, and 101 is not divisible by 7, not by 11, so this is a prime number. So we divide by 101 and 1. So we will have, instead of 2020, that we have 2 to the power of 2. Actually, we immediately exponentiate with x. So 2 to the power of 2x times 5 to the power of x times 101 to the power of x plus 2 to the power of y equals, and now we need to factorize also 2024 to write down the right-hand side of our equation. We divide by 2, this is 1012, we divide by 2, this is 506, we divide by 2 again, this is 253, and now okay, I can divide this by 11, obtaining 23, and 23 is a prime, so we are done here. So this is 2 to the power of 3, actually 3z, because we exponentiated z also, times 11 to z times 23 to z. So we have some powers of 2 here, and also here, and also here. Okay. And exponents on the left hand side are 2x and y. So my idea is to distinguish three cases. First case, when 2x is equal to y. The second one, when 2x is greater than y. And the third one, when 2x is less than 1. Okay, if in the first case is 2x is equal to y, we can simply put 2 to the power of 2x, which is equal to 2 to the power of y. These two expressions are now equal. So we can put that expression in front of the parentheses, and we obtain 5x times 100, 5 to the power of x times 101 to the power of x plus 1 equals 2. So I simply write again the right hand side. Okay. And now, okay, what I want to achieve here. So we will have a solution in this case because our initial guess x equal to 1, y equals to 2, and z equals to 1 is in this case. So this case will have a solution, obviously. So I know that this is odd number. So power of this is the only power of 2 on the right hand side. On the left hand side, this is not the only power of 2 because this expression in parentheses is even. But what I know is that 5 is congruent to 1 modulo 4. So 5 to the x is also congruent to 1 modulo 4. 101 is congruent with 1 modulo 4. So to the power of x, 1 will stay x. So 101 to the power of x is also congruent to 1. So this whole expression in parentheses is congruent to 1 times 1, which is 1, plus 1, which is 2 modulo 4. Okay. So we know that this expression in parentheses has only one factor equals to 2. This is not divisible by 4. It is divisible by 2 and it is not divisible by 4. So how can I write this down? So we have 2 to the power of x times 2 times odd number, which is actually 5 to the x times 100 to the power of x plus 1 divided by 2. And we now know that this is odd number. And on the, I still write down at the right hand side as it is. So what I can conclude? I can conclude that we have that exponent of 2 on the left hand side is 2x plus 1, and that the exponent of 2 on the right hand side is 3z. So these two are equal. 2x plus 1 is equal to 3z. This is what we know now. And our initial solution here gives 3 equals to 3. Okay. And so I can cancel out this and this. I know that this is now true. And I can then multiply by 2 to obtain 5 to the x times 1001 to power of fx plus 1 equals 2 to 11 to the power of z times 23 to the power of z. And now I will try to prove that only solution is x equal to 1 and z equal to 1. Okay. So what we'll have on the left-hand side, I will now write this in more compact form. I actually don't need those factors anymore. I will write down this as 505 to the power of x plus 1 equals 2 times 11 times 23 is this number here. So 253 to the power of z, and actually z is from here, z is equal to 2x plus 1 over 3. So I have this 2x plus 1 to the power. And so it is pretty much obvious that this cannot have as solution some big x, because the basis of exponential function on the left-hand side is much bigger than base of the exponential function on the right-hand side. We need just to estimate somehow to prove what x can be and what x cannot be. So so it will be pretty much obvious if I will not have these two, but we can simply, okay, I will call this left-hand side as L. And this L is equal to, I will write this like this, 505 times 505 to the power of x minus 1 plus 1. And this is obviously greater than 5005 times 5005 to the power of x minus 1. I neglect this plus 1 simply. And also, this is greater than 2. Simply this 505 is greater than 2 times 253 to the power of x minus 1. Simply this 505 is greater than 2023. And we have positive exponent, no negative actually. So, and this will be greater than or equal to this right hand side, let me call it D, or R if you want, no matter, if x minus 1 is greater than or equal to the real exponent on the right hand side, which is 2x plus 1 over 3. And when we multiply with 3, this is equivalent to 3x minus 3 greater or greater than or equal to 2x plus 1, which is equivalent to x greater than or equal to 4. So x greater than or equal to 4 cannot be the solution because left-hand side is obviously greater than right-hand side. L is greater than D here. So we only need to check x equal to 1, x equal to 2, and x equal to 3. Can this be a solution? Okay, well, some calculation is needed here. Okay, I shall take a calculator here. For this, we know that x equal to 1 is a solution if we take 505 to the power of 2 plus 1. This should be divisible by 2, which is, but it also should be divisible with 11 to be equal to the right-hand side in any possibility, which is not, so x equal to 2 is not a solution. Okay, let us try x equal to 3, 5005 to the power of 3 is this big number, plus 1 is this. It is obviously even number divisible by 2, but it should be divisible by 11 also, which is okay, which is interesting. So let us try to divide by 11 again. No, okay, it is not divisible by 11. So z should be 1 because it is not again divisible by 11. And this number should be now 23. So we don't, it was divisible by 11, but this is not 23, and we can check whether is this divisible by 23. It is interesting. It is divisible both by so if x is equal, but this is not, this cannot be solution because it's not satisfied. This anyway, this is not satisfied. X equal to 3 will mean actually that z is not an integer. So yes, it was interesting that that number was divisible by 11 and 23, but it is not a solution. The only solution is x equal to 1. Okay, so we now have and x equal to 1 is obvious solution because with x equal to 1, we already know that this is solution, but here we have simply that with x equal to 1 and z equal to 1, that 506 is equal to 506. Okay, so in this first case, we only have our initial guess as a solution, x equal to 1, y equal to 2, and z equal to 1. Now, we move on to the second case. So now, this was the solution for the first case. Now I move on to the second case, this one. Now I can put 2 to the power of y in front of parentheses, and to obtain 2 to the power of 2x minus y times 5 to the power of x times 101 to the power of x plus 1 equals to the right-hand side, which is this. And now I actually know, because 2x is greater than y, that this is even. So this will be even, and plus 1 will be odd. This is odd, and also this is odd. So actually we need to have in this case that this power of 2 is equal to this power of 2, because there are no other factors 2, neither on the left-hand side, neither on the right-hand side. So in this case, we need to have y equal to 3z, and we can simply cancel this and this. So we now have that 2 to the power of 2x minus y times 5 to the power of x times 101 to the power of x plus 1 is equal to 11 to the power of z times 23 to the power of z. Okay. So is this somehow possible? Or can we prove that this is not possible for positive integers x, y, and z? Hmm. We already know that this is congruent to 2 modulo 4. Actually 1, sorry, plus 1 was 2. So this was given here. And 1 times 1 is 1, so this one is congruent with 1 modulo 4, and the right hand side is congruent also to 1. Why? Because 11 is congruent to -1 modulo 4. 12 is divisible by 4. So 11 to the z is congruent to -1 to the power of z. And 23 is also congruent to -1 modulo 4. So to the power of z is congruent to -1 to the power of z. And if we multiply, we obtain -1 to the power of 2z, which is 1. So the right-hand side is congruent to 1 modulo 4. Okay, but this is possible. Here we have +1, so this should be divisible by 4. And actually it is always divisible by 4 if 2x minus 1 y is greater than or equal to 2. So we have to have at least 2 in this exponent. We have at, uh, at least 2 in this exponent, and then this will be divisible by this will be divisible by 4. So in this way, I cannot prove that there is no solution, and I also don't have a clue that how to get a solution. So I need to find another way. Hmm. Okay. What else can we conclude here? So in this case, y is equal to 3z, but okay, z is any positive integer, y is divisible by 3, and x is big enough, so yes, in this way I cannot conclude anything. But maybe well, okay, let me try also to see what happens when I look at to divisibility with 3, because in a similar way, I have that 11 is congruent with -1 modulo 3, because 12 is also divisible by 3, so 11 to the z is congruent to -1 modulo, to -1 to the power of z. 23 is congruent 23 is congruent to -1 modulo 3, and 23 to the power of z is congruent to -1 to the power of z. So this whole right-hand side is congruent to 1 modulo 3 also. And as we have +1 here, so this should be divisible by 3, and it is not, obviously, because 2 is not divisible by 3, 5 is not divisible by 3, and 101, those are prime numbers different from 3. So this is not divisible by 3, and +1 cannot be congruent to 1 modulo 3. So we have a contradiction here. So by looking at divisibility with 3, we get to contradiction. So this case is not So this case is not possible. And we finally have this last third case, this one here. Now we can put 2 to the power of 2x in front of the parenthesis. And then we have 5 to the x times 101 to the x plus 2 to the power of y minus 2x equals 2 to the power of 3z times 11 to power of z times 23 to the power of z. And now we know that this is odd and that this is odd, and so altogether with this is odd, because this one is even, because this exponent is at least 1. So we know that this exponent of this potential, this power of 2 should be equal to this power of 2, that we have 2x equal to 3z, and that we can cancel this and this. So we know this now, and after this cancellation, we obtain that 2 to the 5, excuse me, to the power of x times 101 to the power of x plus 2 to the power of y minus 2x is equal to is equal to 11 to the power of z times 23 to the power of z. Okay, can we in a similar way conclude that this is not possible? It seems that again, just let me see. We already know that um, this is congruent to 1 modulo 4. And again, we will not achieve nothing this way, because this is also congruent to 1 modulo 4. We know this from before, and so this should be divisible by 4, and this can be achieved if this exponent is greater than or equal to 2. So this way we cannot conclude that there is no solution. Can we again use divisibility with 3? Okay. We know that this is congruent with, as before, with 1 modulo 3 written here. And also 5 is congruent to minus 1. 5 is congruent to minus 1. And 101 is congruent to minus 1 because 102 is divisible by z. So in a similar way, we conclude that this guy here is also congruent to 1 modulo 3. We are done. Let me just check that I didn't make a mistake. 6 is divisible by 3. So this 1 here is obtained as minus 1 to the power of x. 102 is divisible by 3, so we have again minus 1 to the power of x, and this is this 1 modulo 3. In a similar way, we already know this, so this guy here should be divisible by 3, and it is not, as this is power of 2. This is not divisible by 3, so we again get a contradiction here. So we indeed have only one solution. Our initial guess, x equal to 1, y equal to 2, and z equal to 1. Thank you for watching. Thank you for watching and see you next time. Bye bye.